Hi everybody. So in this video, we are going to continue with Chapter 2, Functions, Equations, and Inequalities. Specifically with Topic 2.2, Rational Functions. So we have already studied rational functions somewhat, and let's remember that those are functions in this form. R of x is equal to f of x over g of x. So f and g are polynomials. And the domain of the function R is the set of all real numbers, not including the real zeros of the polynomial g. In other words, g of x cannot equal 0, therefore we have to discard whatever values of x give us 0. In this course, we're going to consider rational functions where the numerator and denominator are linear functions. Some examples of such functions are p of x, where you have a constant 3 divided by a linear function x minus 5, and q of x, where you have two linear functions, 4x minus 2 divided by 2x plus 5. So the domain of function p is all real numbers x, not including x equals 5, right? Or you can write it in this form: x belongs to the reals, x does not equal 5. And the domain of function q is x belongs to the reals, and x cannot equal negative 5 halves. Okay, so let's take a look at example 2.8. And it says, find the domain and range of h of x is equal to 1 over x minus 2, and then sketch the graph of h. Okay, so from the previous section, we know that the parent function of h of x is the reciprocal function. We know that that is f of x is equal to 1 over x. And we know that that function, if we draw it here on the Cartesian plane, looks somewhat like this. Okay, and then if we have h of x equal to 1 over x minus 2, this is simply a shift 2 to the right. We also know that x minus 2 cannot equal 0, therefore x cannot equal 2. So that's going to be the vertical asymptote. So we know that then we would have to draw the function more or less as follows. So we know that the domain of this function is going to be x belongs to the reals, but x cannot equal 2. How about the range? Well, for the ranges, remember that for these rational functions, we have to think in terms of limits. So what is the limit as x approaches positive or negative infinity? And that's for this function, right? 1 over x minus 2. So notice that as x increases here, whether it's positive x or negative x, it's going to be 1 divided by a large number. Therefore, this is going to tend to 0. And we can see the horizontal asymptote here on the graph. It's y equals 0. Therefore, we can say then that the range is going to be y belongs to the reals, but y cannot equal 0. Now, with these reciprocal functions, sometimes people get confused and they draw them this other way. So basically backwards. So one way to avoid this mistake is by plugging in some values into the function itself. So I'm going to get rid of those red lines. And now let's analyze these tables here. So notice that when you plug in negative 98 for x, h of x is negative 0.01. So it's getting close to 0. That's what we see here. We see the function approaching 0 from the negative side. And if you plug in negative 8, you get negative 0.1. If you plug in 0, you get negative 0.5. That's the y-intercept, which you can see right here. If you plug in 1, you get negative 1. If you plug in 1.5, you get -2. And notice that as you approach 2 from the left, right? As the values get closer and closer to 2, as you can see here with 1.9, 1.99, 1.999, this starts getting smaller and smaller. That's why you see this graph just going down as it approaches the value of 2. On the other hand, if we take a look at how the graph reacts to x approaching 2 from the right, notice that if we plug in 102, that gives us 0.01. That means that as x increases, the graph approaches 0. And then if we come closer to 2 from the right, we go to 12, that's still 0.1. 4 gives us 0.5. 3 gives us 1. 2.5 gives us 2. And then as we get closer and closer to 2 from the right, so notice that 2.1, 2.01, 2.001, so this is closer and closer to 2 from the right. Notice that 2.001 gives us 1,000, and that's why you see that as the graph approaches 2 from the right here, it starts going up into positive infinity. So let's continue with example 2.9, and it says, consider the function f of x is equal to 3x minus 8 over 2x plus 6. Sketch the graph of f and identify any asymptotes and any x or y intercepts. Use the sketch to confirm the domain and range of the function. So this is the case where we have two linear functions instead of only one in the denominator. So we have a linear function in the numerator and a linear function in the denominator. So this is going to make things a little bit more complex, but it's doable. So first of all, let's find the asymptotes. And we're going to start with the vertical. So the vertical asymptote is going to be where the denominator equals 0. So if we equal 2x plus 6 to 0, the solution to this is x equals -3. So this is the equation of the vertical asymptote. For the horizontal, we can see that it's going to be 3/2. Now, this is informal, right? So we would say 3/2 equals y, or y equals 3/2. This is kind of informal because I taught you guys a quick method, which is just looking at the coefficients of the x's, right? So 3 divided by 2, 3/2. If we had to do this in a formal way, which we will have to do in the future when we go into calculus, we would do it this way. So let's call this formal. So formally, we would say, what is the limit of f of x, the function, as x approaches positive or negative infinity? So what we do in these cases is that we divide everything by x. So notice that we could rewrite the function as 3x divided by x minus 8 divided by x, and all of this over 2x divided by x plus 6 divided by x. And then we would have to think about what happens when we plug in very large values for x. Now, in the numerator, we know that this would cancel out. And then if we plug in a big number here, this would tend to 0. In the denominator, we would have something very similar. This would cancel out because x over x, regardless of the number x, would cancel out. But this would tend to 0. Therefore, we could rewrite this as being equal to 3 minus 0 over 2 plus 0, and this equals 3/2. So that gives us the horizontal asymptote in formal terms. How about the intercepts? So let's work over here. For the intercepts, finding the y-intercept is easy because all we have to do is plug in 0, f of 0. And f of 0 is going to equal 3 times 0 minus 8 over 2 times 0 plus 6, which in turn is going to give us minus 4/3. That means that the y-intercept is going to be 0, comma, minus 4/3. And then for the x-intercept, we would have to find the value of x that makes the function equal to 0. Now, since the denominator cannot equal 0, that depends on the numerator. So what is the value of x that makes 3x minus 8 equal to 0? So we solve this for x, and we're going to get that x is equal to 8/3. Therefore, the x-intercept is going to be 8/3, comma, 0. Okay, so here we have all the information written down. We found that the vertical asymptote is x equals -3, and we can see it on the graph here. The vertical asymptote goes through x equals -3. The horizontal asymptote goes through y equals 3/2. We have that here. And then we have the y-intercept, which is 0, comma, -4/3. We can see that point here. And the x-intercept is going to be 8/3, comma, 0, which we can see here. So now we have to determine the shape of the graph itself. Remember that the asymptotes are not a part of the curve. They are simply indicators of where we draw the graph. So in order to decide whether we draw or whether we sketch the graph below this point here or above, we will have to test some values to the left of x equals -3. So let's do left of x equals -3. So let's say we do f of -3.1. Notice that that's to the left of -3. And this is going to equal then 3 times -3.1 minus 8 divided by 2 times -3.1 plus 6. So regardless of what this gives us, it's going to be a negative divided by negative. And we know that this equals positive. So that means that f of x will be positive for values before x equals -3. In formal language or terminology, you would say that what's the limit as x approaches -3 from the left? Well, you would say that this, right, the limit of f of x would be positive infinity. So that means that from the left side, we have to start on the positive. Now, because 3/2 is the horizontal asymptote, it means that it comes very close to 3/2. And then as it approaches -3 from the left, it starts shooting up, going to infinity. We can assume that on the other side, it's going to be the opposite, right? It's going to come up, right, from -infinity, cross the y-intercept, cross the x-intercept, and then approach y equals 3/2 from below. But we're going to verify that. So we would say what happens to the right of x equals -3. Well, we can test something like f of -2.9, which is to the right of -3. And this is going to be 3 times -2.9 minus 8 over 2 times -2.9 plus 6. So notice that this is going to give us negative over positive. Therefore, f of x is negative, right? F of x false. In formal language, we would say what is the limit of f of x as x approaches -3 from the right? We would say that it is -infinity. In other words, we say the graph falls. In the other case, we would say that the graph rises. So yeah, it's true, right? The graph falls as you approach -3 from the right, as we can see here. So now we're going to go to the GDC and verify these results. So in the GDC, we go to y equals, and we plug in the function. Notice that we have to use parentheses. Calculators are pretty stupid, so we have to very clearly indicate what we want. Since we want the whole expression 3x minus 8 to be divided by the whole expression 2x plus 6, we have to use parentheses. So parentheses 3x minus 8 divided by parentheses 2x plus 6 close parentheses. And then we hit graph, and there we are. Notice that the asymptotes are not included in the graph. The asymptotes are something we use to assist us with the graph. But notice that we would have x equals -3 right here, right? X equals -3 would be this line. And then the other line that we found was for the horizontal asymptote, which we said was 3/2, and that would be 1.5, so more or less here, right? Okay, so finally, we need to state the domain and range. So it's easy because we have all the information and we verified everything. So we know that the domain is going to be x belongs to reals, but x cannot equal -3. And then for the range, we say y belongs to the reals, but y cannot equal 3/2.